Hello, Mr. Minnick here, helping my students understand the Maze Project demo program. Here's the code as it currently exists in 2017, 2018. And let's first minimize all of the functions. Notice how I put all the functions in one area of the program. From this point right here where it says functions in this comment, down to where it says main program. So all the area in between, notice it's all functions. And here's what we can do with functions, at least in Trinket. You can click these little triangles to minimize them and shrink them. So that's convenient when you don't really need to make any changes to the functions and you want to collapse and save space. So let's study the program, and even if we haven't studied the functions yet this semester, you can still take advantage of them in this project. When this project executes, the player can move the graphic around with the arrow keys, and when the graphic hits a wall, or at least at some point on the wall, maybe not the first touch of it, it resets back to the start. And right there, it reset. Well, at the top of the project, I set this constant in all uppercase letters, a variable, but that's really a constant. I don't want to change it at any point later in the code. I set it to 1, and that's the distance the player moves each press of the arrow key. So if you want to move around faster, just change that to 10, run the project, and you can see that the turtle zips around. And when it hits walls, it resets back to the beginning, back to the start. Okay, so let's be able to change that to any number that you'd like. And the starting position of the turtle. I use the numbers negative 180 and 180 because that puts the turtle in the upper left corner of the maze. But in your grid interface, you might want the turtle to start somewhere else. So let's say I want the turtle to start in the exact center. Then I would change this to 0, 0. Now I don't want to delete these two numbers because I might forget what they were. So I'm going to put a 0 there, but then hashtag comment out the negative 180 so it's still there and I can see it to remember that number later. Now when I run the project, because I changed that to 0, 0, the turtle starts in the center of the maze. And it still resets whenever it hits a wall. So because of my use of constants, notice because they're in all uppercase letters, somewhere in this code, oh, it must be inside one of the functions, the constant move amount is used. Now I happen to know that it's in all 4 of these move related functions. For example, in move up, there's the use of move amount. So move amount is equal to whatever number happens to be there. That's really, you could think of that as being a 1 because it's a constant set equal to 1. Okay, so trust these constants, they're handy. I'm going to set them back to where they were a moment or two ago, negative 180 and 180 for these two constants. You should always explain constants with nice little comment statements over here to the right so that other coders and programmers can understand what the purpose of these constants are. Okay, the first area of this project is review from earlier in the semester. You can figure out how to put background graphics or change the turtle's icon to a graphic, perhaps by making changes here to the screen and the initial player turtle declaration statements. Okay, the program ignores functions. They don't actually execute until they're called into action by another line of code. So what we're going to see is all of these functions, which I put nice little rows of hashtag comment markers there in between them, these can be ignored right now. All the code that's inside that function, for example, can be safely ignored. Notice though that all of the code inside the body of the function, and this is the code that's considered the body of that function. Wow, that's a big function. I can tell it's in the body because it's all indented. All of this code, as I scroll down slowly, is indented until we get to right here, which is the next function. DEF is the beginning of a function. So all of this code from line 101 and back up to the line of code 26, that's all part of a function named drawMaze. And the name of the function always comes after the word DEF. Okay, again, I'm going to skip over the functions, which right now aren't really necessary to understand. And we always execute the code or trace over it in our brain at least, the code that's now in the main, what I call the main program. This is code that's not indented. So this code right here, even if we haven't studied yet this semester or this school year, this code makes it so that when the up arrow key on the keyboard is pressed, then the Python knows to call into action the move up function that I named move up. I could have named it anything I wanted to, but I named it move up. Move up, don't worry, how it works. Just know that it moves the player up. Well, that makes sense because when you hit the up arrow key, you want to move up. Hey, when you hit the down arrow key on the keyboard, the move down function is called into action. So move down, don't worry how it works. There's the code. Its little comment statement embedded there tells you that you should trust that it works the way it does. So please, when you're working on this project, do not change the code that's indented underneath any one of these function DEF lines of code. Just let it be. I recommend that you shrink it up like this and you ignore it all. It just has to be here, kind of like the engine of a car. You should keep the hood of the car closed and don't change wires and mess with things inside the engine under the hood. Okay, so that's an explanation of these lines of code. They match up to the arrow keys on the keyboard. Oh, by the way, the lowercase of the letter R calls into play the function named reset player. Now, if I had named that with a capital R, it would not work. It had the spelling here of the function name. The function name is up here after the DEF, must be exactly the same as what's here. And the letter R must be pressed in double quotes. And just trust me, Python knows that the word up, down, left, and right match up with the arrow keys on the keyboard. There are other special keys like the space bar and maybe the shift key. You'd have to look those up to understand what you would type in the double quotes if you want your code to respond to those other keys on the keyboard. Okay, next the computer does this. Well, that's a call statement for the drawMaze function. If you didn't notice it closely, we scrolled down past it, drawMaze. Once the computer gets to line 218, which is immediately when this program runs, it gets this far, it calls this function drawMaze. So basically, it stops executing code here. It does not do the reset player yet. And it just comes up here to drawMaze and it executes whatever code is in the body of that function drawMaze. So this is where we bring into play another turtle object, not to be confused with the player itself, but we name a turtle pen. We make it have a speed of 0, which means it draws this maze really, really super fast. And we print the words start and finish in certain spots where we want a start and finish to be printed with the right command, the right function. We also are drawing these 4 boundaries along the outside with this code. If you trace this out, you'll understand that. And then all the horizontal lines, H1, H2, and H3 are all being drawn by the code that's in these nice little sections. Because I wrote this code to show good style, I put nice comments that explain, for example, If you look at the design grid that goes along with this project, from the point -200, 130 to the endpoint 120, 130, there's a horizontal line. Well, that's drawn because of this code right here with pen up, go to, pen down, go to, and pen up. Now, as of now, according to the specs, if you here in 2017-18, you do not need to have H1 show up on the final program that you hand in. But I did it here just to be nice, and I put that label H1 so it sort of matches the H1 that you should have put on your actual graph grid paper for to help yourself understand this code. Okay, so each of these 3 horizontal lines are being drawn by all this code, which remember is indented for good style. Be sure that even one single line of code is not indented any further, or this project will not work. See, we get an error message. It says bad input on line 55. It's just basically bad indentation. So you must have all of the code inside of each function. The code must be indented the same amount. Okay, so draw maze works. It draws the maze as you saw, and it also draws vertical lines, and you would have to put code in here for your project to have different lines. You'd have to change these numbers, of course, in the draw maze function. Now, isn't that nice how the function draw maze draws the maze? And none of this other code has to worry about the maze being drawn because it was all tucked in nicely in that one function. These other functions have, of course, other jobs to do. Well, that brings us now to this line of code which executes reset player. Well, in that function, it's pretty simple. It just puts the player in that position, which for me is in the top left corner. Remember, all code that's in uppercase letters like that is usually a constant. So -180 and +180 are the numbers that plug in for those 2 constants right here. So we've just positioned the turtle named player, using the goto command. We positioned the turtle right there. We could have typed a -180 there, but it's just easier to fix this program and update it by putting the constants up here where you can more easily change them and not rely on having to find them like a needle in a haystack in one of these many functions. Okay, then the computer listens to the screen. So basically, when it listens to the screen, that means anytime there's a key press, it associates one of these functions with the key presses. So that screen.listen has to be there. Just keep that at the bottom of this code. And don't mess with player done. That just needs to be there. Okay, so right now the program just waits for the player, the user, the human, to press one of these 5 keys on the keyboard, up, down, left, or right arrows, or the lowercase r. Of course, if you want to upgrade this program and do something else interesting, you would be able to type in a function of your name, like dance, and you could make the letter D. But then that function dance would have to be your own function, and you should name it, you'd have to name it dance, put empty parentheses and a colon, just like you see all these other functions, and then indent code right here that does things. And then every time the player, the human, presses the letter D, this code would execute because it's indented inside the body of the dance function, which links up like this. Okay, we are not adding the letter D on the keyboard to this this function. Let's take the program back. I'm going to make sure it still works. Yep, it's still working right now. And now let's trace the code inside move up. The move up function takes the built-in function y coordinate, and it figures out where the turtle currently is, the turtle named player. And it adds move amount, which, if you remember, was a constant equal to 1. So it takes the y coordinate, which right here, the y coordinate would be the, I think it's the top edge of the turtle. It's either the middle or the top edge. So that would be about the point y equals 180. And it adds, this code adds 1 to that. So the 180 is now equal to 181. And that number 181 plugs into a variable that I named new y. And we are now using the built-in command setY to move that turtle just 1 pixel up. Watch. When I press the up arrow key 1 time, and it just moved up ever so slightly 1 pixel because of this code changed the 180 to 181, and it put the player there. Now, every time you move up, every single time you press the letter, an arrow key, I mean, you should check for a collision. Well, the code for checking collisions with all the lines is placed into this function called checkCollision. So all of these functions, move up, move down, move left, and move right, anytime the player moves to the right, to the left, down, or up, every microsecond, checkCollision is being called into action from one of these functions. So check it out. If checkCollision equals true, then reset player. See how that's indented as part of the if? Don't forget, you have to indent the body of an if statement. Just like the whole if statement, which is like both of those lines of code, is indented inside that function. So the line of code reset player here is tabbed in 2 levels of indentation. It will not work correctly if you have the reset player there. And certainly it will not work if you have it there. Oh, it might do something, but it would do something that's totally logically incorrect. Okay, so how does this actually work, this if statement? Well, if statement control expressions are true overall, then the code inside here resets. Well, this is a call statement to the function checkCollision. And in that function checkCollision, I'm going to unveil it now for the first time. The very bottom, it returns false. And that false plugs in here. And then you have to ask yourself, is false equal to true? No. Overall, that would be a false. And if you have a false with an if statement's control expression, then it does not execute reset player. So basically, anytime you move up and you did not hit a wall, you do not reset. Anytime you move to the right and you don't hit a wall, you do not reset. Anytime you go down or to the left and you don't hit a wall, you reset. But if, on the other hand, checkCollision simplifies to true, then because true is equal to true, overall we would have a true, and we would execute the code reset player, which right now, just trust me, this function reset player, it does reset the player to the top left corner in my project. So why, under what situations does checkCollision turn into a true as opposed to a false? Well, again, we have to go look at the actual checkCollision function to see how it works the way it does. So all of that collision detection logic and if statement that we'll soon see, they're all buried inside this function here. But look, it's a lot of code. All this code is indented inside that DEF checkCollision. So it's quite a bit of code right here. That's the code that's checking to see when that turtle hits any one of these lines. Well, the first section of checkCollision only checks the boundary lines which go around the outside. So basically, for example, the left boundary right here, if the player's x coordinate, which means it's where its left edge is on the x-axis, if that x coordinate ever becomes less than negative 200, right there it's about negative 199. If our turtle was right here, its left edge would be negative 199. But the moment it hits the x value negative 200, that's equivalent to saying that it hit the left edge of this grid. So at that moment, when it hits the left edge, you could either have a double equals here or a less than or equal to. Either way, it should then simplify to true if it hits that left edge. And if an if statement's control expression is true, then the computer does this. So what does it mean when we hit a return true? Well, that means that the true value goes back to where check collision was called into action. So it's kind of like sending an envelope back to the person who mailed it to you. This true goes back up here. And if you remember, all of this perhaps came from the situation where we moved left. And if the player ever moves left, I was in move up, and I should have. Let's pretend we're in move up. If we moved up, and the top edge becomes, in this case, if check collision, the top boundary, if it becomes greater than 200, which means the turtle went up and its top edge becomes greater than 200 right here. That would be its y value, its y coordinate. If its y coordinate, the top edge, becomes greater than 200, that means it's off the grid. And again, that could be a double equals or a greater than or equal to symbol. They both should work. And this check collision returns a true. As soon as the computer gets to one of these if statements that is true, the return that's right under it will return the true. And all of these return trues right here would end the execution of this function check collision. And the computer would send that value back up here where it would then reset the player. So it all works, and you can experiment with it, but the important thing is in this project, if your boundaries are the normal 200, negative 200 and such, don't change this code. But in this area where I nicely marked off collision detection for horizontal lines, that's where you would change the code. And I have another video that explains how you would change these numbers, or how you would copy and paste this if statement and add more if statements to the right area. Oh look, that would not work. That I is not lined up with that I. You would have to keep all these ifs lined up nicely, and all the returns must be, I would say, lined up nicely. And then you would change these numbers accordingly based on another video that explains how the collision detection works. Well, the collision detection actually works pretty well for horizontal lines, in that if a turtle is, for a horizontal line, if a turtle is right here, let's see here, if a turtle is right here, its top edge would say be 153. If it moves down a little bit, its top edges would be about 148. If it moves down to about right here, its top edge perfectly hits this line at the point 130. So if at any moment of time, its top edge is 130, then we know that this is true. And at the same time, if its x-coordinate, which means its left edge, is greater than or equal to negative 200, now this is all for line H1. If its left edge is greater than negative 200, so greater than negative 200 just means that basically the turtle is somewhere over here and that the turtle is not over here, because its left edge here is greater than negative 200. The number like negative 185 is indeed greater than negative 200. So by checking to make sure its top edge is equal to 130 on the y-axis and its left edge is somewhere over here greater than x equals negative 200, that helps us determine that it may have collided with horizontal line H1. But we have to consider the possibility that it's over here, where its top edge is on the line y equals 130, and its left edge is greater than negative 200. But here, the turtle is supposed to be allowed to walk around the end of that line H1. So we also have to make sure that the left edge of the turtle is less than the number 120, because only if it's less than 120 would it indeed have collided along this line. So in the code, we have finally here the code players x, this is x, not y. If its left edge, which is this x position, is less than or equal to 120, then we know that that's true. So when you have an if statement's control expression that has a true ANDed with a true, those two would simplify to true. And then we have yet another true ANDed with a true, and that would all simplify to true. And therefore we return true, which means we do not continue checking for collisions with other walls. We immediately return a true. And that means that this function, check collision, is returning the word true back up to where it got called. So that means this was all analyzing whether it was move up, and it doesn't matter if it's moved down, because that's where we're checking collisions also, moving left, and of course moving right. Those four call statements for check collision all end up simplifying to true if the code down below that we analyzed determines that the little turtle has hit any one of these lines. Okay, well, read the lecture notes, see the teacher for help, perhaps get valid help from another student, and to understand the collision detection that's built into this demo project further. I'm going to now undo all my changes, make sure the code still works, and it looks like it does. And the last thing we have to figure out is how it resets. Well, anytime that it moves and there's a collision is true, we call the function reset player. Reset player right here is pretty short. It's only about 3 lines of code. We hide it so it's not like visible, so it doesn't move across the screen. And we simply send it to its starting position, and then we show the turtle again, just so it's not glitchy. So reset player resets it, and the human can continue to press keys and move around. One last thing I'll throw out there is that in check collision, some collisions are actually good things. Oh, by the way, if none of these return trues ever are encountered, then it returns a false, because it's the catch-all. We could have put an else there, but that would not be particularly wise in this particular demo program. I don't want to get into it. Just trust me that the return false there does happen if none of these if statements above it return a true. But look at this last if statement that I put right before the return false. This is wind detection rather than collision detection. I simply imagined a vertical line right here between the point roughly here at negative 170 and right here at the point negative 170 down to the point x equals negative 170. But from the point y equals negative 110 to the point y equals negative 200. So by imagining an imaginary line here, this if statement checks for collisions even though it's not really a line that we see, it's there, and if the turtle collides with it, then we send the turtle, it looks like, actually we don't send the turtle anywhere. We, we send the turtle to negative 50, 0. We use the turtle's pen to make the message, congratulations, you finished the maze. Now check this out. Knowing that that position is there, I'm going to temporarily position the turtle at the point negative 150 and let's say y equals negative 150. And I'm going to run the program with the turtle starting right here, which is right to the right of my finish line. So I'm going to move the turtle around and show you that there are no collisions, otherwise it would be resetting. But now watch, I'm going to slowly hit that imaginary line. And as soon as our code in that collision detection function determines that I hit that line, it briefly hides the turtle there and displays this message, congratulations, you finished the maze. And that all worked because in the collision detection function, I put this extra if statement. And good luck with that if you want wind detection built into your project. Now I'm going to, before I forget, change my starting position back to negative 180 and positive 180 and test it one last time here. Yep, okay, it's working. Okay, some other little tips here besides just the understanding of how this project works with the functions and a little bit of the collision detection. Always check your indentation, make sure it's exactly correct. Python is very strict with indentation. Other tips, watch all other videos that I have that would help you with this project. I do have at least one other one. Another thing that you can do is sometimes if you're having trouble with, say, some of your collision detections, you could say you don't want to have to go around this horizontal line. So you could put this special kind of comment marker, 3 little apostrophes there and 3 little apostrophes there. Everything now in between that spot and that spot, which is all the nasty collision detection for horizontal lines, is now commented out. So to test this V1 to see if it's working, I can now, like a ghost, pass through that wall. And I could even come over here and pass through horizontal line 2 because of what I just did over there on the left. And I could now test to see if V1 does work. And look, it does reset. It's good enough. It's all because I temporarily commented those 3 if statements out. Now I'm going to take away those 2 sets of 3 apostrophes. And that's a nice little tip to debugging your project. Some people, instead of separate ifs, they might change all of these ifs to one if with elif. That may or may not work. It all depends on the logic of your project. See me for extra help on that if you're having trouble with it. But for at least in 2017-18, separate if statements is fine to get a good grade on this project. And last of all, I will stress to you, make backups, especially if you're using Trinket's website here like this. So when you're done with a project, save it. I recommend duplicating it, keeping extra copies of it in your account at Trinket, and then just naming it like I did here. This is like a copy. So I sometimes have like 5 copies of the same project or more. You could also, and I don't discourage this at all, I recommend it, highlight all the code once you're done working on your project, copy that code, and perhaps place it into a blank Microsoft Word document or a Google Doc or someplace. Save a copy of it somewhere so that you don't lose code, especially at trinket.io. Microsoft Word is a perfectly good place. I don't like its font choice, but there are worse evils in the world than the font. I'm sorry, I just lost track of where it was. You can change its font in Microsoft Word to the Courier font if you would like to make sure it looks like it does in a Trinket or some other program that you're using to do idle code. And you could also change the landscape there of that document to change its orientation to landscape. And then your code at least is backed up, and then of course you would save that file with some name that would make sense to you, and you would save it somewhere. Okay, those were some tips on how to understand this project. Good luck, and work hard.